Hello and welcome back. In this video, we will be discussing scatterplots. Okay, so we have a handful of definitions to go over first. Let's take a look at these. So, what is a scatterplot? A scatterplot is a graph that displays between two quantitative numerical values by plotting each pair of values as a point on a coordinate plane. Okay, we have our explanatory variable, which is our x variable. The variable used to explain, predict, or influence changes in other variables. This is our variable placed on the x-axis. Our response variable, y, the variable that is measured or predicted based on the explanatory variable placed on the vertical axis, the y-axis. We have a positive association, which is a relationship in which as the explanatory variable increases, as the x variable increases, the response variable, y variable, also increases. The points generally move upward from left to right. This will be more clear with a visual illustration. Likewise, for the negative association, more clear with a visual representation. This is a relationship in which as the explanatory variable, the x variable, increases, the response variable, y variable, tends to decrease. The points generally move downward from left to right. No association. This is a relationship in which there is no clear pattern between our two x and y variables. Knowing the value of one variable does not help to predict the value of the other. Again, the three of these will be much more obvious with visual representation, which we will get to. A linear relationship. That's a relationship in which the points follow an approximately straight line pattern, either increasing or decreasing. Okay, so we want our positive and negative associations to kind of mirror like a straight line looking thing, which we will see. An outlier, something we've gone over. This is a data point that lies far away from the overall pattern of the data. An outlier may affect the strength of the relationship, the correlation, and the regression line. Outliers skew our data. And lastly, an association. This is a relationship between two variables. An association exists if knowing the value of one variable helps to predict the value of the other. Okay. All right. Let's take a look at an example. So in this given example, we have hours studied versus test scores. And just a quick note so hours studied is our explanatory variable, where test scores are response variable. Explanatory variable 99% of the time is going to be some form of time. Okay, time is always associated with x. Sometimes they even just use t instead of x because it's so common. Anywho, we're comparing our study to test score. So here we're given a range of 1 to 8 for hours studied, and we're giving a range of test scores. Okay, so our first step is we're going to take this and list it as an ordered pair. And I could have wrote them a little bit closer together, but they line up with each other. The first elements go together, second, third, fourth, fifth, sixth, seventh, and eighth. That's the pairings we're going to make with each other. As you can see, I did here. Okay, so just to drive that home, we pair together 1 and 58, 2 and 65, 3 and 68, 4 and 74, 5 and 79, 6 and 84, 7 and 88, and 8 and 94. And just to make it a little bit more clear, what I'm going to do is just add here 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4, 5, 6, 7, 8. So it's more clear to see what's being paired with what. I could have wrote the numbers neater to make it more obvious. I'll fix that before I upload the video. Or sorry, upload the notes. Anywho, step 1, list as ordered pair. Okay. All right. Step 2, we're going to start building our scatter plot. And we're going to start with our, it's escaping me, what is called a coordinate plane. Thank you. We're going to start with our coordinate plane. Now, if you notice, I constructed mine. The x-axis is hours. We have 1 through 8. The y-axis is scores. So I looked at my scores. The lowest one's 58. The highest one's 94. Okay, so I made mine between 55 and 95, and I had to go up by intervals of 5. It's nice and consistent, nice and easy. And remember, we always put our break when we are skipping a bunch of things, okay? label the axes, boom, got this built. All right, step 2, plot each ordered pair. And you can see they are all plotted here. 1 and, I don't remember what they are off the top of my head, 1 and 58. I put it roughly there because it's between 55 and 60, 2 and 65, 3 and, what is that, 67? 3 and 68. Okay, close enough. In the middle there, 4 and 74, 5 and 79, 6 and 84, 7 and, what is that, probably 88? Yep, 7 and 88. And then 8 and 94 here. Okay, so like, I would recommend when you're building these, don't kill yourself with making them perfect, especially if you're doing it by hand. If you have software, it'll make it perfect for you, but like having it, if it's 99% perfect, where with the what's the word? I'm thinking zoom because I was just looking at a calculator. With the scale, if that's good enough. Like you don't have to kill yourself. You're gonna draw the same results one way or another. Okay. Anyway, step 3. Plotting order pair. Now, step 4, look for the observed pattern. Okay. We're going to come back to this and talk about the patterns. I mentioned them over. I don't mention all the patterns here. Okay, that's fine. Either way, I'm going to mention the patterns coming up, but there's 4 patterns we can remember. The 4 characteristics of a scatterplot. DFSO. Now, this is easy for me to remember because one of my favorite bands is called DSO. So I just remember the F is in between the D and the S. Dark Star Orchestra. Check them out if you haven't. Anyway, the 4 characteristics of a scatterplot, DFSO, are direction, form, strength, and outlier. Direction, form, strength, outlier. That's what our letters stand for. Direction we talked about, positive, negative, or no association. Form, linear or nonlinear. We're only going to be focusing on linear in this video. Strength, moderate, strong, moderate, or weak. An outlier is there an unusual observation. We're going to take a look at what this looks like, but just to give you like a heads up of what a proper response would look like. If you have your model, you would say your response is something along the lines of, I gave this example. The scatter plot shows a moderately strong positive linear association with no obvious outliers. Anytime you describe your scatter plot, this is the type of language we're going to use to describe it. And like I said, we're going to do more examples. All right, so let's take a look at some. So here is an example of a strong positive association. Okay, so the direction is positive. As X increases, Y also increases. It generally goes up from left to right. Okay, and it's strong because like the points are so close together going this way. This is almost a straight line. And that's what we write over here. As X increases, Y almost always increases. The points lie very close to an imaginary line, and like that imaginary line would go like here. And we're gonna go into much greater detail about these imaginary lines, but not for the sake of this video. Anyway, the points lie very close to an imaginary line, so predictions are very reliable. We can predict easily, like if X is 5 and Y is 5, based on this, we can easily predict that if X is 10, Y is 10, and we can see here it close enough is. Now, why? Because the points, why is this strong positive association? Because the points stay tightly clustered around the trend line. There's very little scatter. Scatter is how far the points would go from our imaginary line. And you can see I just draw this quick line here, and almost every point touches it. So again, scatter is how far the points stray from our imaginary line. Okay. What does a moderate positive association look like? So you can see here in this one, we can still draw our imaginary line, but the scatter is greater. It's still somewhat packed together, but definitely not as much as the first example. So this one we would consider moderate. And here I write, as X increases, Y generally increases. We can confer that, but there is noticeable variation. Variation being how far what's another word I can use? Deviates from our line, for back better term. How far, like it kind of strays from that imaginary line. Why? The points still follow a trend, but are farther from that imaginary line than a strong association. Okay. And then as you can imagine, here's a weak association. We can still see we have this trend going on, but the points scatter even more away. Much more so than in this example here. So there is only a slightly upward trend and predictions are not as accurate. So here, like see, okay, we predict 5 is about what we'll call it 2. So that should mean 10 is 4, right? Wrong. 10 is about 9. So we can't as easily make our predictions, but we still do see this imaginary trend line here. And then y, the points loosely follow the trend with substantial scatter. Okay. No association. This is all over the place. We can't predict anything based on this. This looks like looking at a starry night. There's no consistent upward or downward pattern. No X provides essentially no information about Y because the points are randomly scattered. All right. And now we're going to look at the negatives, and the negatives are the same as the positives, but the opposite direction. Here we have an example of a weak negative association. Negative because as X increases, Y decreases. We have a downward line going. And while the downward trend exists, the points are widely scattered from this imaginary line that we've been talking about. So as you can imagine here, a moderate negative association, again, negative because as X increases, Y decreases. But for our imaginary line, while there's still scatter, that's a terrible line, but you get the idea. While there's still scatter, it's not as bad. And then strong negative association, more of the same. As X increases, Y decreases. We have a decreasing line here, but the points are tightly packed around our imaginary line, so the association is strong, but still negative. All right. So, I don't want you to look at that. I'll block it in the editing for now. But for this example, here's the example we have. I drew our imaginary line here. I just kind of eyeballed it. There's much better ways to do this, which we will go into, but for now, eyeballing it is fine. We could see for our imaginary line, 1, 2, 3, 4, 5 out of 8 of our points touch the line. 3 of them, are slightly off. So we could say this scatter plot shows a strong positive linear association with no obvious outliers. All the points are very close to this line. Okay, cool. And this is the basic idea for scatter plots. We're going to be talking about this a lot. All right. Some common mistakes, confusing correlation or association with causation. Again, correlation does not imply causation. I'll go more in detail about that later. We cannot ignore outliers. Another mistake, using qualitative or categorical variables in scatter plot. Scatter plots are only for numerical data, and forgetting both variables must be quantitative. Again, we're only using numerical data for scatter plots. Cool. So here I give a practice problem, and just like before, just to make it a little bit easier on the eyes. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so we could just to make our ordered pairs a little bit more obvious. Here we have hours of sleep versus reaction time. We're going to plot the given data on a scatter plot and describe the relationship using DFSO. Feel free to pause here and take a stab at this. Cool. All right. Hopefully we worked at it. Let's take a look at what we get. So, very first thing I do here is create my ordered pairs, which makes plotting it much easier. Now, when we plot the ordered pairs, again, x-axis is going to be 4 through 10. It's our hours slept. Y-axis is our reaction time in milliseconds. We do our break line here because we skip. So in the x-axis, sometimes you see break lines, sometimes you don't. It's not as important. I've done it in previous videos. It's not as important to have your break line in the x-axis, but in your y, we must be mindful of that. All right. So now when we plot these, now the line given, now I just kind of eyeballed this. I didn't use a formal equation, but I know it's going to be somewhere around here. I might be off a little bit, like it might be somewhere, something like this, but it's close enough. This gives the general idea. And maybe it's a little bit further down like this. But here, we could say that the scatter plot shows a moderately positive association. It's really packed down here, and it's still kind of close up here. So it's close enough to call moderate. Maybe we can stretch and say it's, what's the last association, weak? Yeah, we could stretch and argue it's weak. Again, I went with moderate just because at the bottom here, these ones are so close. But we do have an outlier that kind of stretches everything out. Our point 10 is an outlier. And that's what brings this down. If this point 10 didn't exist, this would look more like that. This would be a very strong association. But this is our outlier, which skews our data, and it's going to bring it down to more like this because this point needs to be accounted for, and it's going to bring this whole down. I'll show you the math behind that in an upcoming video. But for now, we're just kind of eyeballing it and just trying to get the idea down. So if you said it was moderately or weak, those would be acceptable for the purposes of this video. But it should definitely be positive, and we should definitely account for this outlier over here. Cool. And of course, lastly, all of our graphs, give them titles. But cool. This is everything I have for you on Scatterplots. We're going to go into more detail this in upcoming videos, but this is just to give you an idea of what we're talking about. Okay. Thank you for tuning in. As always, a link to the notes will be in the video description, and I will see y'all next time. Take care.